Good afternoon, everyone. Today we're here to discuss the basics of hydraulics, and we will, in this section, examine some of the components that make up a hydraulic system. So, why use a hydraulic system? You will be probably aware that hydraulic systems are almost universally used, whether in cars, in the braking systems of the cars, construction equipment, airplanes, vehicle repair and maintenance. A very familiar sight would be a car jacked up for servicing, which is again an application of hydraulics. Dishwashers at home also use hydraulics to increase water pressure for effective cleaning of the machine. So, why use a hydraulic system? A, because they transmit energy efficiently and easily. There is very little loss of energy through friction, and they almost completely eliminate the need for complicated linkages, gears, shafts and other mechanical components. So fundamentally, we'll be looking at 5 major components of hydraulic systems, starting with the tank, the pump, the motor, the control valve, the hydraulic cylinder and the actuators. And finally, we will also look at how they all come together as one integrated system. In this section, we'll be taking up the hydraulic tank, the design of a tank, the function of a pump and the function of a motor. The hydraulic tank, as is obvious, is the reservoir holding the hydraulic oil or the hydraulic fluid. It has an inlet and an outlet. Baffle plates are provided to prevent the hot return oil from going directly into the outlet. They also are equipped with measuring devices such as dipstick, sight gauges or level plugs. So at any point in time, we're able to check the levels of oil that are there in the tank. They are provided with openings or ports to change the oil, clean the tank and also change the filters periodically. Looking at a hydraulic pump, the hydraulic pump may be considered the heart of the hydraulic system, which is a mechanical source of power that converts mechanical energy into hydraulic energy. It gets its power from a prime mover, which is normally a diesel engine. There are many types of hydraulic pumps, and we look at the top 3. The gear pump, which is basically comprising of 2 gears meshing together and creating the hydraulic flow. It's a simple and economical design, and they push out oil by the meshing of these 2 gears, the teeth of these 2 gears. Piston pumps, as is evident from this picture here, consists of multiple pistons which are mounted in lines parallel with the central line of the pump. And you can also change the angle of the swash plate to allow for less or more displacement. So, another version of the piston pump is the radial piston pump, where the pistons radiate out from the center of the pump. We also have a vane pump, which have slightly more efficiencies than the gear pumps, essentially the principle being the same. A vane that moves in and out of the rotation shaft pushes out the oil. We'll now have a look at the hydraulic motor, which is in one sense an exact reverse of a hydraulic pump. They are powered by the fluid that is pumped out from the pump and transfer rotational kinetic energy to mechanical devices. So again, there are 3 types of hydraulic motors: the piston motors, the gear motors and the vane motors. Very similar in construction to the pumps, but performing the exact opposite function. So the torque is the motor output power, turning force on the drive shaft of the motor, and torque, as you know, is a product of the force and the distance. The output torque is determined by the pressure, and obviously the hydraulic pressure is high, the torque is higher, and the speed of the motor, the speed of rotation of the motor is determined by the volume of incoming oil. The greater the flow rate, the faster the speed. So with this, we have covered 3 key components of a hydraulic system, and in the next section we'll be taking up the other components of the hydraulic system and how they all come together to perform as an efficient integrated system.